it is live. Good afternoon to our audience. Welcome to today's ESA Hangout to talk about the VMC imaging campaign. And our plan today is to basically run this as a tutorial for anyone who is participating or anyone who wishes to participate. You still have more than a week if you wish to sign up. My name is Daniel Skruka. I'm the Senior Editor for Spacecraft Operations here at the European Space Operations Center in Darmstadt, Germany. We're speaking to you today from the Mars Express Mission Planning Room. As you can see, it's an actual operational area. We have some activity going on behind us. Stuff happens here. We're flying the mission from here. And I'm joined today, starting on my far right, by Andy Johnston. He is one of the spacecraft operations engineers working on MEX.
Yes, that's correct. Yeah.
And Simon Wood, just to his left, also one of the operation engineers working on Mars Express, and Michael Kahn, who is working on the mission analysis team here at ESOC, and very, very keen and passionate about Mars. And in fact, all of us are. And if you're watching, you probably are too. So thank you very much for joining today. What I'd like to do, we're going to run this for approximately an hour or so. And first of all, let's be clear about how you can send us your questions. We're actually watching live. We've got some assistants here in the room. You can't see them, but they're off camera. We're actually looking at Twitter. So if you tweet a question, please use the VMC Schools hashtag, VMC School with an S hashtag. We'll see those tweets. You can post a question in Google+. In fact, if you're watching the video screen on Google+, you should see somewhere on the video box, there's an option for questions. If you click on that, it'll pop up, and if it doesn't immediately pop up, there's that Google grid square appears in the top right, and you can click on that, and you'll have the Q&A app will open, and you can post questions right in Google+. And if you're watching via YouTube, in the ESA channel on YouTube, you can actually post a question as a comment underneath the video window, and we'll see those. So we'll see all of those. And of course, after the program, if you still have some questions, you can always email us via vmc@esa.int. Good. Let's talk a little bit about the VMC imaging campaign. It's actually a really cool thing. We're very excited about it, and we're glad to see that a lot of you are already. We've received quite a good number of applications, and we hope most of you, or even all of you, are watching right now, depending on which time zone you're in. We are actually going to hand over VMC to you in the sense that obviously we can't actually bring you here to ESOC to sit in the room and press the buttons, but we're actually going to take your requests, your imaging requests for this camera, and program those into the Mars Express mission planning system. And on a 3-day period in May, roughly between the 25th and 27th, the pointings that you have requested, the targets that you have requested, will actually be carried out by Mars Express, and we'll send you those images back to you when they're acquired. And your part of the activity, of course, is that we're looking forward to see your project, and your project is wide open. We want to see something scientific, something collaborative, something artistic, something really cool, as best as you can do with those Mars Express images. Quick rundown of the dates, just so that you keep these in the back of your mind. 27th of March at 12 noon CET time on the 27th of March. That's the cutoff for registrations. If you already have registered, that's great. We've seen them in the system. You're free to go back and amend your registration after today's tutorial. If you change your mind about what you want to see or about the kind of projects you want to do, it's no problem. You can go back and re-register. Just use the same name and the same email address so I can match them up with your first registration. It's no problem. If you have not registered, please do so. Go to esa.int/VMC. You can go to various URLs. esa.int/VMC schools. That will work. Go to esa.int/VMC_imaging_campaign. That will work. Or go to the ESA homepage and look under the recent news list. You'll see the article announcing it. It gives you full instructions on how to register. So if you haven't, please do so by the 27th. On the 8th of May, we will announce, we'll have reviewed all the applications, so give us about a month. And the reason why we need that month is to be able to reconcile some planning issues, and we'll talk more about that later on today. On the 8th of May, we'll announce who has won a slot, and we would love to be able to give slots to everybody who applies. Basically, we will be time limited in the sense of there's only a certain number of slots available. And once the pointings are all reconciled, there's only a certain number that we'll be able to conduct within this 3-day window in May. So not everybody who registers necessarily will get a slot. That's the way that is. But on the other hand, we will give as many as we can to the best possible proposals. And if there's any possibility that we can share images so that you can still do your project, we'll make sure that happens as well. So our aim really is to get as many eligible applicants as possible to get them a set of images once this is finished. On the that'll be on the 8th of May. On the 25th to 27th of May, that's when we'll actually conduct the images, and we'll tell you more about that later on. And just afterwards, on the 28th of May, we will download and distribute the images as quickly and as directly as we can. And then you'll have until the 31st of July or until your school year ends. That's okay too. Certainly no later than the end of July to submit your project, which we look forward to seeing and we look forward to sharing with the world via our Mars Express blog. Now then, if you want to find out more information about the campaign, as I say, look on our website, look on our Mars Express blog, that's blogs.esa.int/MEX. And of course, you can just Google VMC and you'll find lots of information. Okay, without too much further ado from me, I want to pass over to Andy Johnston and ask him if he could do a quick overview of Mars Express, the planet, and the mission.
Okay, well, Mars Express itself, it's got a very brief overview. It was Europe's first mission to Mars. Next year we're launching our second one, the TGO, the Trace Class Orbiter. It's been in orbit around Mars for 11 years now, and still producing good science data. Now, the VMC camera itself was originally just for one part of Mars Express. That was for the Beagle lander when it was released. VMC was there just to photograph it as it went out. As for do you speak more about the VMC itself?
No, we'll jump into that later. Yeah.
Okay.
No, just Mars and Mars Express.
Well, Mars itself, it's of a lot of interest to us because we're hoping to learn a lot more, well, basically the planet itself, but also a lot more about our environment, which should help us with our atmospheric modelling and analysing how geology happens throughout, well, on all planets really, and that should help us understand our own world a lot more.
Now, correct me if I'm wrong. In the 12 years now that Mars Express has been orbiting Mars, we've had some firsts, have we not? We have detected water.
Yes, subsurface water.
We have detected methane, and we have, with our HRSC camera, operated by our DLR colleagues, or through our DLR colleagues, we've come up with a 3D map, basically, of the planet. So Mars Express has done some really cool stuff.
And still going strong.
Still going strong, yes, yeah. And hopefully Mars Express will bridge us through to the next mission coming up in a couple of years' time when we launch.
Next January.
Next January, exactly. January, yeah, that's right, right after Christmas. We launch ExoMars EDM entry.
No, TGO and EDM is the two spacecraft.
Right. Together.
One's going down the surface and the other is in orbit.
Right. Okay. Good stuff. Okay, that's the mission, that's the planet, and obviously VMC can see a lot of very cool features on the surface, and we'll get into that now. And actually, Andy, what I'll do is, if you want to take over this seat,
yes, we'll do.
I'll get your PowerPoint working in the Hangout.
Okay.
And hopefully it's going to work, and I'll flip the button as you talk through.
No problem. So I promise this won't be death by PowerPoint. It's not too boring. Just a quick overview of VMC and what sort of quality of images we can expect and the limitations of it.
Yeah, I'll just
yeah, no problem.
use the PowerPoint.
Okay.
Share screen. Just a moment. That's good.
Okay, if we just.
There we go, and I think it's this one, and okay, we're now sharing.
Okay, if we just go back to the very start of this.
Yep.
And,
I was on the last
so
slide.
quite a few.
There we go.
So this is the VMC itself. So you can see the matchstick beside it just for some scale. This is just basically, it is a space qualified web camera. It was designed and built in the 1990s along with the rest of Mars Express. So when you compare it to like the camera on your cell phone, it seems very, very primitive, but it still functions very well. And again, all it was supposed to do was just record the release of the Beagle lander. And since we reactivated it a few years ago, we've actually got some very, very good images of Mars. So yeah, it's quite good. So some things to think about when we take some images with this. First of all, Mars is smaller than Earth. So we need to take this into account. Also, Mars is quite a bit further away from the sun than Earth is, so it gets a lot less illumination. And another thing to take into account when we're doing these images is, if we could just go ahead, is that Mars Express does not have a circular orbit, so our distance from the planet changes throughout our orbit. This image shows, it's taken actually from a discussion about our Phobos flybys, but you can see that in the top of the picture, we're about 300 kilometers from Mars, and at the bottom of the picture, we're our furthest point away. We're roughly 100,000 kilometers away from Mars.
10,000.
Sorry, I'm very tired today. So 10,000 kilometers from Mars. Thank you for correcting me. So what I want to do is just using Google Earth. I just wanted to sort of mimic what VMC images would look like if we took them over Earth. So our farthest point out of 10,000 kilometers. This would be the field of view of VMC and roughly the image quality. Okay, this is obviously a Google Earth image, but I just thought it would be easier for people to understand if I use that. We can still make out the landforms. We can still make out deserts, mountains. We can still recognize what we're looking at. So the quality is decent, but it's not amazing. Now, if we were to sort of zoom into the center of this image, and then we would see what it would look like from 300 kilometers, which would be our closest point to Mars. And here we have this desolate, uninhabited part of the world called Scotland. You can see now that we can actually start to make out, even with this web camera, we can still make out lakes, mountains, just about make out cities and civilization. Okay, obviously we don't have these things on Mars, but this is just so you can get into your mind what the capabilities of VMC are and what to reasonably expect from it. Now, if we just move on a bit, I want to just discuss where VMC is mounted on Mars Express and the angle it's pointed at. Now, if you look at the orange marking, VMC, well actually, let's talk about the blue first, because VMC is pointed off slightly at an angle. Actually, I can show you in the model if we swap back to just the camera again. Okay, so we've got the Mars. I'll come up closer. We have the Mars Express model here. So all of our sensors are mounted on the top. So all of them point directly away from this surface of this face of the spacecraft. Apart from VMC, it's angled at. It's actually mounted about here. It's angled at 19 degrees towards this wing. That was because Beagle was mounted in the middle here, and it was to get a good view of Beagle as it's separated and released. So if we just go to our next image on the PowerPoint thing, I can show you what that normally means in our observations with VMC. Now I'm going to ask you to sort of flip between two images kind of quickly so that we can see, if we just move to the next one. So in the left-hand side, there's sort of looks like a coffee cap stain, this dark crater. That's Gale crater where Curiosity currently is. Now if we just flip between these two images and back again, just kind of rapidly, you can see that Gale crater stays in the same point in this image. That's because our main instruments were pointed at Gale crater at that time. The VMC is pointed off by this 19 degrees. So this is what we normally end up with when we do a flyby. So if you do an observation with VMC. But for the summer, we're actually be pointing the VMC up wherever is requested to do so. So we won't get this offset. And yeah, and this also gives you a rough idea of the sort of images we can get. I don't know, would you like to talk more about the the planning side, or would you like to discuss more about the images of?
Yeah, talk more about the images. We'll ask
Okay.
Simon to go ahead.
If you just go back one again, just the Becquerel crater one. If you see where Mars meets space, we can just see along the edge there. We can see some clouds. So VMC doesn't just pick up landforms. We can also pick up things in the atmosphere too. And if we just go down to the next one, we can see again this one. It's quite overexposed, but it does show some quite nice cloud layers forming there. And if we move on again, these are sort of my favorite VMC pictures without put these at. I don't know whether it's sunrise or sunset, but we can start to see the light coming through all these cloud layers over Mars. I think this was back in 2009 we took this image. And I think what we could do now then is we could talk about some of the features on Mars, and maybe Michael could help me out here. He's a lot more knowledgeable about the surface itself. So here we have Elysium Mons, and I quite like this image because we get some nice shadows from it, and it gives the idea of how tall these volcanoes are. Would you think like to add on Elysium Mons?
Well, actually, south of Elysium Mons are these two. This will be to the left, bottom left, and we have we would have Elysium Planitia. That's a plane where next year in September an American probe is going to land. It's called InSight. So actually, this is a site which is of interest for science. It's not just it's well chosen.
Okay, if we just move on to the next slide, we can just see these are the more famous volcanoes on Mars. So we have off to the largest one being Olympus Mons, and
Yeah, Olympus Mons is the one to the right. If you look at this triangle, this is the vertex of this triangle. And then this line, this crater chain, this volcano chain. In the middle you have Pavonis. On the one end you have one called Astreus, and the other is Arsia Mons. Pavonis is interesting because it's right on the equator. And who knows, one day we might have a space elevator on Mars, and a good place to put the surface space for the space elevator would be on the equator, and would be right on the summit of this mountain.
okay, if we just move on to our next one, we've got Hellas here, which is an impact crater, if I'm right.
Yeah, probably. It's a huge depression, a huge impact crater, and it's about 8,000 meters deep, so 8 kilometers deep. It's like Mount Everest upside down, but it's vast. It's enormous. And the interesting thing about Hellas is that if you look at where it is from where in the previous picture we have these volcanoes, it's just about 180 degrees opposite. So, and these three volcanoes is on a huge uplift zone, something that came up, and I think it's generally believed that it has to do with this. So something that the impact created a shock wave that ran through the planet and created and pushed out some material on the other side. Okay. So without this impact, we wouldn't have the huge volcanoes on the other side.
And the next slide we move on to, we've got Argyre. I pronounced it right. So it's another I really like this image as well because you can see again up towards the Terminator where the light meets the dark. You can get some very nice shadows across the craters up there, and again it really shows the 3D effects, well, the 3D surface of Mars. And if we just move on to the next one, we can see one of the more famous landmarks of Mars. We've got Valles Marineris, and the next slide also is a bit further out, and possibly a bit better lighting here. But yeah, I mean, this also kind of gives you an impression of the scale of Valles Marineris. It is a vast formation.
I think it's said that it's 10 times more of the Grand Canyon in every dimension. So 10 times deeper, 10 times longer, and 10 times wider.
And if we just move on to, we've got the poles as well. So the South Pole, and which is not quite as spectacular. If you move on to the next one, I had to do it though because the North Pole is just, it's much prettier. And this is, we did a low-level pass over this when we made, we did some full orbit observations with VMC in the past, and we got this image, and it really is amazing considering this is taken by a webcam. So I quite like this, and also just this next image doesn't show very much, but it's just nice. I think just the crescent of Mars. Although this,
and correct me if I'm wrong, that's one of the first images that we got from VMC when we recommissioned it in
that's correct,
2007.
yeah. Although also at this time in 2007, there was also a global dust storm on, so I'm not sure how much you would have seen on the surface, but it's just quite a nice image, I think. It doesn't show very much at the surface, but I just think it's quite pleasing. Now, the next two slides we've got are sequences. Now, this one shows the clouds at the poles. This is the North Pole, and we can see the clouds as they evolve over time. I'm sorry, I don't have a time scale for these. I just picked some that really show the difference on how these things do move and change. And this last sequence of 4, you've got to look quite carefully. You will see that there is this small black dot, and as we go from top left to top right, and then the next to the bottom, you'll see this black dot moving down. That's actually the shadow of Phobos as it crosses Mars.
That's cool.
It is quite cool, and we actually got it. We didn't realize at the time we were going to get this. Okay, if we'd have discussed it more with the mission planners, they would have, the flight dynamics, the mission plan, they would have told us when we could expect to see this, but we just caught it by accident, and it was a really, really cool event. So, okay, this is sort of the end of my sort of best of VMC slideshow, and we've got some videos we can show which are used for planning, and also some we made up of our long full orbit observations. Don't know if you want to show them now, or do you want to save them at the end, maybe?
Let's save this for the end. Maybe
Okay.
we'll switch back to the camera.
Mm-hmm.
And okay, we should be back on there now. And
Okay, I'll give you your seat back.
thanks. Okay, we'll just swap back out. Okay, thank you very much, Andy. That was good. And I see a couple of comments. A couple of people were just saying if we could speak up a little bit, just project your voice towards the mic a little bit. We've brought the mic a bit closer. I hope that works better now. We'll just make sure that Andy is
That's all right.
still on the camera there. Okay, good stuff. Okay, so I think you've got a pretty good idea as to what VMC can do, and I do want to ask one question, Michael. What's your favorite target? I mean, of those images that we just saw of Mars, what?
Far away, Valles Marineris.
Valles Marineris. Okay. All right. So that's one possible target for imaging, and VMC, as you can see, shows it in pretty good relief. And I like the fact that you do get a 3D effect, and you do get shadows. And I think you can do some calculations of those shadows as well. We're going to pass on to Simon and ask him if he could talk a little bit about the VMC campaign, how the planning is going to work, what we're going to do with the pointing requests that you send in, and talk a little bit about the process and some of the tools that you can use. And I'll pass over to you, Simon.
Right.
You know PowerPoint, right? So I'll just
No.
Okay.
Okay, I mean, I guess the thing to sort of start with is going to be why are we doing this now, and why does it have to happen at the end of May? And the reason for it is that we enter a period in May, or sort of in the beginning of end of May, mid-June, called solar conjunction, and we have some props.
I'm going to do our solar conjunction props. Okay. You be Earth,
Okay.
and I'll be.
So
You be the sun, and I'll be.
what's effectively
I'll be
happening
Mars.
towards the end of May
Here we go.
is that the Earth and Mars are effectively going to be on opposite sides of the solar system. So the sun is essentially in the way. Now, in the lead-in and lead-out of this period, that actually produces some interesting chances to do some science, because we actually do radio soundings of the solar corona. But for normal spacecraft communications, that's pretty bad, because the communications will be disrupted. It'll be, there will be a short period when we pretty much can't command the spacecraft at all, and communication is just not going to be reliable for a period of time until the Earth and Mars move effectively far enough away from the sun. So the consequence of that is that we don't run the instruments, the normal science instruments, during this period, which helps us from the point of view of the VMC, because due to technical reasons and the way in which it is connected up to the spacecraft's main computer, we can't really run the VMC whilst the main science instruments are on. So we normally do our normal observations with it at the point at which we do our wheel-off loadings when we would normally have the instruments off. And so what this has thrown up, because there's now going to be this period where the instruments aren't going to be on, and it's fallen just at the start of our normal planning cycle. So it was decided that we would not plan any observations at the end of the previous cycle, which now gives us sort of 4 days before we actually enter the solar conjunction configuration. And so we've now got this period where we don't have any science pointings, and so potentially we can now actually add in VMC pointings at a position we wouldn't normally be able to do.
I just want to bring up that point. It's very interesting. All of the VMC images, or the vast majority that you've seen so far publicly, either today in our in Andy's presentation or in the Flickr channel, on the VMC blog, in the MEX blog, those images are normally taken at about 10,000 kilometers, where it's the full disk of Mars. And during this 3-day opportunity May, we're actually going to be able to command VMC to acquire images at more or less any point in the orbit. As you saw, that orbit is getting very close to Mars. We could be getting shots from just a few thousand or even a few hundred kilometers.
Yes, I mean it's something.
So actually, the schools, the groups, the clubs that take part in this campaign are actually going to be able to get VMC images that nobody has ever gotten before. Is what it comes down to.
Yeah, it's certainly that's very much the case. And once we realised that we had this opportunity, and to take the type of images that we hadn't really been able to do before, it was then a question of, well, what should we take? What should we image? And we then sort of hit on the idea that, well, actually, we've always, VMC was reactivated with the intention of doing outreach and doing educational activities with it. So the idea was, well, why don't we ask the public, what would you want to take a picture of? And then we very quickly hit on this idea of, well, let's get schools involved, let's get clubs involved, and youth groups and the like, to propose observations.
Good stuff. Could you actually just talk us through what will be the process when we close the window for submissions on the 27th of March up until the 25th of May, when the observations take place? What will the team here do with the imaging requests?
Right. Okay. Well, we will be treating this essentially in the same way that we would do any normal science observation requests. So what we're actually going to be doing is exactly what we do with real instruments. That the pointings will have to be created, and this is one of the reasons why the cut-off date seems quite early, considering that actually we don't do the observations until the end of May. Is that we need time to be able to create the actual necessary pointings, because as Andy was saying before, if we get to Mars Express, the VMC is mounted around about here. And the instrument platform on Mars Express is completely fixed, it's rigid, it doesn't turn at all. So if we want to take an image of a particular point on the planet with any of the instruments, we have to physically turn the spacecraft and aim it at that position. So we have to go through and basically create the necessary pointings to say, okay, right, this point over here at this point in the orbit, and then later on in the orbit, point over here, and then later on in the orbit, point over there, and so on and so on. And these then need to be checked by the mission planning team and mission planning systems, i.e. what's going on behind us right now, actually, to make sure. And we'll be looking for things like power constraints, power usage, because obviously we generate power from the solar arrays, we have batteries, but we have to make sure that at the start of each orbit that those batteries are fully recharged. And some pointings will use more power than others. To make sure that the data rate is okay, that we're not generating way more data than we can transmit. And then once we have all of that, and we're happy that from an operations point of view the plan works, that then has to be sent off to our flight dynamics team. And what they are looking at is specifically that they have a whole series of constraints in terms of how we can point the spacecraft and the sequence of pointings that we can do to make sure that they actually are they're workable and that they're safe. So that for example, we can't point the back of the spacecraft at the sun, because that's where the star trackers are, that's where the radiators are. It will damage them if we do. And there are limitations on how long each face of the spacecraft can be exposed to the sun, to basically getting too hot. And all of that has to be checked by flight dynamics, and so we can't commit to doing a pointing until Flight Dynamics have come back and said, yes, it passes all of our safety checks, and that you can turn the spacecraft at that rate. We can we can hold position at that point, because it may be the case that if we are trying to hold position at pericenter when we're traveling very close to the surface of the planet, so our ground track is actually, we're going very, very fast, and so we have a limit at how fast we can rotate anyway. And so again, that has to all be checked and verified as being okay. And so once we get all of that back, then we can actually sort of say, okay, right, yes, we can run these sets of observations.
So what you're saying is it's a lengthy and complex process, but once we've gone through that, we'll basically have a confirmed list of which observations can be made. Yes. And that's when we can go back to the applicants, the schools, the clubs, the groups that have applied, and we can say, yes, you've got a slot, yes, you've got a slot, or it could be that no, you don't get a slot because we can't image your target. But we'll reconcile everything as best we can.
Yeah, I mean, it's going to be a case of some of the targets are going to look better from higher altitude. Mm-hmm. I mean, I think that the issue that we've got with this particular period is that we've not long since come out of our eclipse season. So that's basically obviously we have an eclipse happening on Earth on tomorrow morning. But, you get them in space quite a bit. So we're currently in a period at the moment where our orbit means that we pass between in a situation where Mars is between us and the Sun, so we don't get any power. We'll have just come out of that in the end of May. So basically, we will be orbiting Mars pretty much along what we call the terminator, so the transition from day to night. And so the pericenter is going to be, at certain positions could be quite dark. So it may be that actually some targets look better from higher altitudes, in which case we may be in a position where we see 2 or 3 requested targets in one picture, in which case we can
team up. Okay, good stuff. Good. So we'll be able to announce in May on the 8th, and after that, then it's just a matter of uploading the commands, generating the commands, uploading the commands, and we wait for the campaign to happen on the 25th to 27th.
Yeah, pretty much. We're going to be again. It's pretty much as we would do normally. We would once we've got everything back, we run the system. We run it through the mission planning system, and it's able to then generate the necessary commands to the attitude control system to turn the spacecraft and aim at the relevant targets, and then once we've got everything in place, then it goes up to the spacecraft, and then the spacecraft does its thing. And then it's a case of trying to get the data back. So,
right. Yep. Okay, and that should happen within a day or a couple of days after the.
Yeah. So obviously one of the issues that we have is that we need a deep space ground station to be able to communicate with Mars Express, and there's a finite number of those and quite a few deep space missions. And so the way it works is to allotted amount of time on each station, and as part of mission planning, what we have to do is to make sure that the data downlink fits within the stations that we've been allocated, and we may have some carryover from the previous month's worth of activities, but we'll have to sort of wait and see with that. But the objective is to get them back as quickly
as possible. Okay, good stuff. Michael, can I pass over to you, and could I actually ask you a couple of questions on, I know you've already looked at the Mars Express orbits during this 3-day period, and I know you've already looked at a list of potential targets. What can you say about some of those targets, some of those surface features? What catches your eye?
Well, as Simon just said, we have a particular orientation of the orbit, and that's just the way it is. So the fact is that the part of the orbit when the spacecraft is high, when it's near its so-called epicenter, so it's farthest away from us, is always above the morning side, the morning, so when the sun has just risen, and where it's low, it's in the evening, so it's dark. Probably it's dark in those locations. It's a bit unfortunate, but there's nothing you can do about that. It's really the way it is. But that just means, on the other hand, that means that you could get nice panoramic views with deep shadows, with large deep shadows, and those are physically, so they're really pretty. If the sun is shining down vertically, then it tends to be bland and boring and just drowning out all the colors and contrasts. But if the sun is low, then the shadows are deep, and it's quite attractive to look at. That would exaggerate the apparent height of hills and the depth of valleys, and it looks really nice. So from the aesthetic point of view, that's nice, but I think it's also interesting to look at this from the point of view of topology, because you can then really understand, it's really to understand what the surface roughness, what the surface features are like. You can really understand what it means to have a mountain on Mars. These mountains are massive.
Right. If we got a clear shot with a shadow of a surface feature, can we actually do some calculations with that? Could we use the basic geometry to calculate the height of Olympus Mons?
Absolutely. If you know the elevation of the sun, and that's straightforward to calculate, there's also some software that does it for you, then indeed it's just simple geometry to calculate how high that feature is.
Okay.
On the subject of the software side of things, we've put on our website and on the blog downloads for, there's a free planetary software.
So visualization background.
Yeah, called Celestia.
Celestia.
And we actually have a Mars Express model for that, and we've basically run it through. We have a little tool we've developed here that actually allows us to convert the real data coming from flight dynamics into an orbit file for Celestia. So it's
could we actually hop back over to your PowerPoint and see that? Do you want to take over my seat there? Well, if this is a good time for carry on.
So what we've done, and I think it is actually currently on the blog at the moment, but we can run through it now. So we've generated basically what our orbit will look like for those few days. And so as you can see, we've got the yellow line is basically the terminator. This is really quite slow.
It's because we're encoding through Google, so yeah. The version on the blog is much better.
Yes, yeah. The version of does run in real time. So as you can see, we at the closest, we spend very little time very close to the planets. So the bulk of it is going to be these views at altitude. And as we said, the yellow line basically is the terminator. So it is the switch from day to night. We find the contrast image in VMC is quite sharp. So I would expect stuff the other side of the terminator to be pretty dark.
Okay, yeah, that's running a little slow on through the Google encoding, but it gives the idea. The full version is in the
as I say, we've put the planetary grid on there just to get an idea of where we are in relation to various features on surface. And so if you've got there's a few topographical maps of the planet. I think there's one that Becquerel used for the ground track plot we've got on the blog, and the US Geological Society's got quite a few as well. So you should be able to sort of tie those up with what you see on there. Okay.
Andy, do you want to go through any more of the slides?
Well, we've got two. It was asked, so one of our questions, would it be possible to make videos up from sequences of slides? So twice we've done full orbits of Mars using the VMC camera pointed down towards Mars, and we can show both of them if hope they run quickly. If not, one of them is already in our Flickr account, and we'll post the other one as well.
That's the first one.
Yeah.
Yeah, it'll run a bit slow here in the Google Hangout, but the phone is in YouTube and the blogs.
Yeah, but also gives you an idea of what Sam said, that as we get closer, the spacecraft gets much faster as it passes over the planet. So this is where this is just coming back out of the dark side, passing over the North Pole, and then going back up to the highest point of our orbit. So I mean, okay, this is time-wise, this was 7 hours. So it's obviously heavily compressed to make it a nice.
And that was Phobos that just.
Oh yes, right at the very end there. Yes, Phobos zips past. This is where we.
If we can replay that. Yeah. If you look, you'll see Phobos coming from top to bottom as a little black dot. Yeah.
So yeah, it's quite nice.
Okay, and I think there's a second version. Nope, that's the end of it.
Oh no, we should have the second.
Nope, that's right. Here's the second version. It was done.
Yeah, this one contains more frames. The previous one, we had 3 different exposure settings on the camera, then chose the best. So we're basically binned 2/3 of our images to make the first video. So this one, okay, it's running a bit slow because of the compression today.
Yeah.
But there's a lot more images in this one. This is the one we've got on our Flickr account. So if people want to look at it, it's probably better if they look at it themselves.
What's on the screen at the moment, you can just see, just going over the just out of shot now, is this is the South Pole. So you can see there's a sort of visible difference in size between that and what you see at the North Pole.
Yeah, maybe it's better if people just look at this themselves off of the Flickr account. It's maybe not too great to show up here right now.
Good stuff. Okay, I think we're almost ready to switch to some questions that people have been sending in, and I want to start off very quickly. We'll do this sort of in priority, and we had gotten some questions from I think it was Dave Pentecost sent these in. I think he's in the U.S. and he's keen to. That's right. He's East Village Planetarium in the Lower East Side Girls Club, New York. Dave, I hope you're watching, and if not, we'll pick it up in the replay. We actually sent in a number of questions. I think we've touched on most of these. We just highlight them. One is, what is the effective resolution of the images from the Mars webcam? And
Well, actually,
yeah, sure.
Sorry.
Sure.
It's not right again. I can just give you some of the numbers to go with it.
I mean, it's sort of probably worth mentioning that. I mean, we refer to it as the Mars webcam mainly because it's the images that you get out of it are basically comparable to what you would have got from a webcam that you walked into a PC store and bought back in 2003.
Yeah.
So that's the kind of.
If we just go back one just now, just to give some of the numbers. I think you asked. Well, from this we can get a rough idea of the field of view. Okay, it's 40 degrees wide. That gives us just under 11.5 kilometers per pixel. That's assuming just the raw values from VMC. Once it converts to color, we start to lose all of that. So it ends up possibly around about 20 kilometers per pixel. And also the field of view, if we were to assume that just with this height of 10,000 kilometers that it's a flat surface, then that's about 7,300 kilometers wide. So this is why on this image of Earth, okay, we can see the curvature of the Earth and the edges of the images, but when we look at this from Mars, the whole globe fits in the image. If we just go into the zoomed in picture, I'll just give you some numbers from that. Okay, at this scale, we're talking around about 1/3 of a kilometer per pixel. Okay, and again, with the compression, when it converts to color, we lose a bit of that. So probably around about 1/2 kilometer per pixel, sort of in that region. And the field of view here, again, assuming it was a flat surface below the center point, would be about 220 kilometers.
And the resolution of each image that's taken is 640 by 480 pixels. It's as I say, it's a sort of standard, typical early 2000s webcam kind of in the image size and the quality. It's like 256 colors as well. So.
Okay. Yeah. Great. So I think you've covered most of what David asked. He also said what's the area of coverage, which I think we've addressed. Can you provide us with sample images? Well, of course, in our blog or in the Flickr account.
There's thousands of Flickr.
There's thousands. He says, will we have access to stills or video or still sequences that can be assembled into clips?
Well, yes, this is what we did. We basically assembled our sequence of stills into video just using software that's available. Well, there's even free software available on the internet that can do that for you.
Right. So VMC basically generates still images.
Yes.
Yeah. The way that the camera software works on board is that we give it a number of images we want it to take, exposure settings that we want it to use, and then it will cycle through those one at a time. It takes roughly a picture a minute.
Okay. A picture a minute. Okay, great. We'll go now over to Google Plus, and I can see there are a number of questions already coming up in the channel there, and I'll look at the first one coming up here, just so we see what we see. We've got. Who's this one? Great. Okay, we have a question from Robert Cahill. And he says, do I need to give a target based on the 9 that we said were best? Michael, that was based on your recommendations that I put in the blog. He says, or do I actually need to give you a target and an actual time when I want you to take the picture?
Well, you certainly don't need to restrict it to the 9 that they were just some suggestions to get you started. I mean, at the end of the day, suggest anything really. If it's, I mean, obviously some stuff will be more possible than others. If you want to have a look trying to use Celestia to work out what you think might work and what wouldn't, then feel free. But we're not necessarily sort of going to go, oh, well, we don't want to take a picture of that. It's up to you guys, really.
And it's just a moment to emphasize that the project that the schools or the groups are going to submit afterwards, they actually could be an artistic project, it could be a scientific project. So really, what you do with the image is kind of up to
and to some extent, in terms of what's actually going to get selected, I mean, the project really is what we're interested in. I mean, we're not expecting you to publish journals in Nature out of this. I mean, okay, if you do, then brilliant. We want to see a good project. We want to see something that's going to really educate people, get people involved, and get people interested and excited about space, science, and engineering.
Great. Okay, there's another question, also in Google+, and it is being asked by someone named Robert Kim, who has said, what is the sensitivity of the sensor, what spectral range, and what wavelengths of light can it observe?
That's a good question.
I'll have to go and if there's specific details, I'll have to go through the manual.
I mean, it doesn't have any particularly fancy filters on it. I mean, it is just designed to take visual images, and it's not looking in the infrared or anything like that.
It really is a 14-year-old webcam.
If you try and take a picture of the night side of the planet, the picture's going to be dark. I mean, we can. The only settings we really can fiddle around with it is the exposure settings, and that's it. Right. So.
And from my experience with the VMC, either it's overexposed, it's underexposed, or it's about right, and that's pretty much it.
Also, we have some damaged pixels on the camera, possibly some contamination on the lens as well. So, sorry, this is not the world's best instrument, but it actually does an awful lot for what was originally intended for.
Good stuff. Okay. Okay, let's just go down the list a little bit more, and let's pick Susanna Kovics, who is asking, is there any data on how long Mars Express could remain operational? How long does?
Well, I think currently we are confirmed up to the end of 2016 and provisionally confirmed up to the end of 2018.
Well, our funding, yes. So the spacecraft itself. The spacecraft itself is still in good health. Okay, eventually we'll run out of fuel, but projected we still have quite a bit left, and battery life is still good for a few more years. But again, there's always the chance something random could happen, and we lose the spacecraft. But so far, it's in good health, and we hope to keep it going for as long as we possibly can. Okay.
The next question is a very good one, and actually I want to pass this over to Michael Kahn, and it's coming from via Twitter. Via Mark Sequeira, who says, can the VMC capture Martian auroras? And we just saw some nice aurora pictures recently. Didn't we? Was it? Oh, I'm not thinking it's not Mars. It was on the NASA one visiting with the water vents. With the
okay.
Yeah, sorry. There we saw auroras, but we don't see auroras on Mars.
Well, we do, but they're not. The problem is they're not in the visible spectrum. So I think Maven has possibly suggested they are, and we may have seen them with some of our instruments. But certainly not they certainly don't look anything like the northern lights you get on Earth. So you wouldn't be able to see them with VMC. It's a visual camera.
Okay. So. Okay, I'll go back into the question list here to see what we've got. Right, it's another one from Mark, and he's asking, will the Martian polar caps be visible during the VMC campaign?
Yes, they will. The southern cap, I think, will be more visible than the northern cap. In essence, I think the southern cap will actually be in its entirety as we go over it. The northern cap will be, but it will be partially in shadow. But as Michael was saying, that maybe that will actually bring out a few more features in it with the shadows and everything as we go over it. I think again, if you have a look on the Celestia video, and if you download and install Celestia stuff yourself, the instructions are all on the blog. Then again, you'll be able to see that.
Okay. And maybe for Michael, I'm just wondering, what is the importance in general terms of studying the polar caps on Mars? Why are we interested to get information about that?
Polar caps are composed of frozen carbon dioxide and frozen water. So, and the areas around that are soaked with permafrost. So actually water in the ground. And there's a big difference between the south and north, because the south is on average 4 kilometers higher, so the density is much lower. And actually it was thought before that it couldn't hold. So we know that there's, because the pressure is much higher at the northern polar cap, we know that there was a lot of water ice. We didn't know before Mars Express that there was a lot of water ice in the southern polar region. Now we know that there is, not just in the polar cap itself, but also in the polar region.
Right. Okay.
It's quite important, because water is really the one thing we're looking for.
Right. Okay. That's very interesting. A question also from one of our registrants, and I'll just see if I can scroll down to it here. This is coming from Paolo Mauricio, who has actually sent in a registration, and he is asking, I'm interested in obtaining an image that reveals geological features of Mars, eventually resulting from basin water flow. Could it be possible, in the sense of obtaining a really interesting image to compare with Earth images that show basin water flow?
So I think what's being referred to here is when fast-flowing river enters a basin and then loses lots of its sediments. It's called an alluvial fan, and that's what geologists get extremely excited about, because when water slows down, all the sediment will settle, and then you have a very interesting deposit. But yeah, looking at it from orbit is probably interesting. At those resolutions, I'm not sure that it will really tell you very much. We're not doing spectroscopy.
But is there? I mean, are there features on the planet that we would be able to see?
Well, it's in all the major. What you need is a large flat-bottomed crater, and there's several of those. And actually, Gale is one, and another one was shortlisted for the MSL for the Curiosity landing site. It's called Eberswalde, and that's on the southern hemisphere. But I think there would be some opportunities for viewing that. In fact, there are quite some sites which were shortlisted for current or previous or future missions, which are visible. So one should really look at those, because if they have been shortlisted, there's a reason for that.
Right. Okay. Okay. Another question coming in. This is kind of interesting. We've already mentioned that it's just a webcam, but the question is: so is there an IR filter, or can near IR show up in the webcam?
I'm not sure. I have to go and check on that. As far as I know, it's just filtering for red, green, blue, just in the visible spectrum. I will go and check, but as far as I'm aware, it doesn't go into infrared or near infrared.
It's a webcam.
Basically, yeah.
Yeah, I mean, its purpose is essentially very much in the name. I mean, VMC stands for visual monitoring camera. As Ellie was saying earlier, that it's attached to Mars Express so that we could basically monitor the deployment of Beagle 2. And so the idea was that you image Beagle as it's floating away, and then our flight dynamics team here can then analyze the images to see that Beagle is actually on target, which we found out at the beginning of the year that it was. There are similar, I think we posted an article on our blog earlier this week, basically, that there are similar cameras on other spacecraft. So when we have things that deploy out, we particularly were interested to see that that actually does deploy. So XMM has a similar camera looking back at its solar arrays to make sure that it was there to check at the point at which they sent the commands to make the arrays unfold that it worked.
Cluster,
Sentinel has it with both the arrays and the radar booms. Because I mean, you have to appreciate that spacecraft, when they're packed into the launch vehicles, it's a sort of impressive bit of origami that goes on, and we need to make sure that these things unfold and work correctly, and the cameras are the best way to do that. So that's why these things are here. It's not, it doesn't have all of the fancy filters that HRSC or HiRise or something has on it. So.
That's appreciate where this question is coming from. The older CCDs, whenever you'd film something hot, it would start to glow because it would start picking up infrared as well as the visible spectrum. So
right.
I will look into it a bit further just to be sure to give you an honest answer.
I mean, we do see some variation in VMC with temperature, but it's usually long exposures when it's been on for a time. So it's, if there's quite a lot of, if there's something to look at in the image, then you usually don't notice.
But this is more when we're doing exposures in the seconds, whereas what we'd be doing here would be in the sort of tens of milliseconds, so it shouldn't be an effect.
One question came up, what is the resolution and actually the field of view is the second question of the camera. I think we've already mentioned that. We said, Andy, you said it was about 1/2 to 1/3 of a kilometer per pixel at 300 kilometers altitude, and that's about 220 kilometers.
Yeah, the field of view roughly is around about 40 degrees.
40 degrees by about 30 high.
And the resolution of the images is 640 by 480.
Okay. Okay, we're coming down to the last few questions here that I see in Google Plus, and just we've already answered that.
Actually, we could mention that this is not far off from normal if you have a camera, a digital camera or a film camera, then and you have a 50. What used to be a 50 millimeter lens is called a standard lens, and that's pretty much the same for.
Yes, in fact, I think that it's a 50 ISO 50 film, I think is what it's been compared to in terms of the imaging quality.
Okay, the sensitivity.
Yeah, the sensitivity. Yeah.
Okay. One question I see asking, will there be any data like position and or velocity vectors available via the Horizons program?
The JPL Horizons website, I think it does offer the
From Earth Express?
It does. It sometimes takes a bit of time to update, because obviously that has to be fed through from here. I mean, we can certainly, once we've got the pointings set up, we actually have in our Celestia tools a script that will actually take not only just the orbit data, but also the attitude of the spacecraft. So it will turn as it would do during the observation. So once we've got all of that loaded and Flight Dynamics have sent everything back to us, we can certainly put that up for download, so you can view it through Celestia.
But yeah, Horizons would be good enough for this project. It's fine.
Yeah. Okay. Good. We're just about coming down to the end of questions here. I see a couple more which we've already answered, and somebody asking, what is the weather like on Mars?
Dry.
Dry.
And cold.
Yeah. Okay. I was just squeezing back on the camera. Good. Great. Okay. Geez, guys, I think we've pretty much answered all the questions. Is there anything any of you can think of that we haven't touched on? We wanted to.
Well, I think the main thing is just to say, you've got another week.
Yes.
Hopefully, in a week or so's time, we've got some very difficult decisions to make. So it's the ones that we've seen so far have been really good.
Yes.
And so if you're thinking about sending one in, then please do.
Yeah.
And if you want to make any modifications to one that you've already sent in, then again, feel free.
Yeah. I just want to summarize for everybody contact. If they want to get hold of us, they can send an email to vmc@esa.int. That'll be seen by all of us. Right?
Okay.
They can post a query in the blog, blogs.esa.int/mex, MEX. We look at that pretty much daily. You can tweet. You can tweet with the hashtag, which is VMC Schools hashtag. We look at Twitter pretty much every hour, if not every minute. So we'll certainly see Twitter quickly. And those are all the main channels I think for all of us. Oh, I'm just hearing one more question that might be a good one.
Do you want me to read that to you?
Sure. Is it? I can actually read it from the screen if. Okay, well, one final question coming in from, I'll just click on select, and it says, Can you distinguish the clouds and dust storms on the basis of pictures taken with VMC?
Yes. Yeah, absolutely. It's actually, I think, something that was a little surprising when it was first turned back on, that we have that ability to do it. And you can certainly, in the previous sets of observations we took last year, you could even see the gradual sort of dust levels increasing around the polar caps over a number of weeks. And in fact, to a point where even one of our instruments is actually interested in using the VMC images when they're looking at the CO2 clouds, because they can detect them with the infrared in their instruments, but actually being able to see them on a global scale helps their research. It's something that we're looking into at the moment.
Good stuff. Good. We'll finish up on the questions. Again, to confirm, people know how to get a hold of us. You've got until noon on the 27th to submit your proposal or to amend your proposal if you've already sent one in. And we're looking forward to working with you. We're very excited about this campaign, and we'll work very hard to ensure that you get as many good pointing slots as possible within the 3-day period. And don't hesitate to drop us a note or ask any questions. This video will be available for replay in Google Plus and the ESA G Plus channel. It'll be in the ESA YouTube channel as well, youtube.com/ESA, and you can review it. We'll post it in the blog when it's done. This video is CC licensed, Creative Commons licensed. You're free to download it, share it, tell your friends about it. There's no problem with that. We're very happy to have you share it. The more the merrier. I'd like to thank Andy and Michael and Simon for joining us today. And I'd like to thank Michel Denis, who is our Spacecraft Operations Manager for Mars Express here at ESOC. He's wasn't able to be with us today. He's certainly strongly supporting this activity and has allowed you guys to spend some of your time. Normally you're a Canadian spacecraft, but we're doing a little bit of outreach today. I'd like to thank very much here at ESOC my colleague Barbara Weimar, who was working off camera way over there, picking up your questions out of Twitter and out of some of the other channels. Thank you very much, Barbara. And I would like to thank very much my colleague at EJR Quartz, Maria Bennett. She's in Leiden. She's also looking at the back end, making sure that everything worked out properly with Google Hangout technology, which is sometimes a challenge. And that's just about it for today. I'd like to say thank you very much for joining, and yeah, we look forward to seeing your submissions. Thanks a lot. That we'll be able to conduct within this 3-day window in May. So not everybody who registers necessarily will get a slot. That's the way that is. But on the other hand, we will give as many as we can to the best possible proposals. And if there's any possibility that we can share images so that you can still do your project, we'll make sure that happens as well. So our aim really is to get as many eligible applicants as possible to get them a set of images once this is finished. On the that'll be on the 8th of May. On the 25th to 27th of May, that's when we'll actually conduct the images, and we'll tell you more about that later on. And just afterwards, on the 28th of May, we will download and distribute the images as quickly and as directly as we can. And then you'll have until the 31st of July, or until your school year ends. That's okay too. Certainly no later than the end of July to submit your project, which we look forward to seeing and we look forward to sharing with the world via our Mars Express blog. Now then, if you want to find out more information about the campaign, as I say, look on our website, look on our Mars Express blog, that's blogs.esa.int/MEX. And of course, you can just Google VMC and you'll find lots. Is live. Good afternoon to our audience. Welcome to today's ESA Hangout to talk about the VMC imaging campaign. And our plan today is to basically run this as a tutorial for anyone who is participating or anyone who wishes to participate. You still have more than a week if you wish to sign up. My name is Daniel Skruka. I'm the Senior Editor for Spacecraft Operations here at the European Space Operations Center in Darmstadt, Germany. We're speaking to you today from the Mars Express Mission Planning Room. As you can see, it's an actual operational area. We have some activity going on behind us. Stuff happens here. We're flying the mission from here, and I'm joined today, starting on my far right, by Andy Johnston. He's one of the spacecraft operations engineers working on MEX.
Yes, that's correct. Yeah.
And Simon Wood, just to his left, also one of the operation engineers working on Mars Express, and Michael Kahn, who is working on the mission analysis team here at ESOC, and very, very keen and passionate about Mars. And in fact, all of us are. And if you're watching, you probably are too. So thank you very much for joining today. What I'd like to do, we're going to run this for approximately an hour or so. And first of all, let's be clear about how you can send us your questions. We're actually watching live. We've got some assistants here in the room. You can't see them, but they're off camera. We're actually looking at Twitter. So if you tweet a question, please use the VMC Schools hashtag, VMC School with an S hashtag. We'll see those tweets. You can post a question in Google+. In fact, if you're watching the video screen on Google+, you should see somewhere on the video box, there's an option for questions. If you click on that, it'll pop up, and if it doesn't immediately pop up, there's that Google grid square appears in the top right, and you can click on that, and you'll have the Q&A app will open, and you can post questions right in Google+. And if you're watching via YouTube, in the ESA channel on YouTube, you can actually post a question as a comment underneath the video window, and we'll see those. So we'll see all of those. And of course, after the program, if you still have some questions, you can always email us via vmc@esa.int. Good. Let's talk a little bit about March. That's the cutoff for registrations. If you already have registered, that's great. We've seen them in the system. You're free to go back and amend your registration after today's tutorial. If you change your mind about what you want to see or about the kind of projects you want to do, it's no problem. You can go back and re-register. Just use the same name and the same email address so I can match them up with your first registration. It's no problem. If you have not registered, please do so. Go to esa.int/VMC. You can go to various URLs. esa.int/VMC schools. That will work. Go to esa.int/VMC_imaging_campaign. That will work. Or go to the ESA homepage and look under the recent news list. You'll see the article announcing it. It gives you full instructions on how to register. So if you haven't, please do so by the 27th. On the 8th of May, we will announce, we'll have reviewed all the applications. So give us about a month. And the reason why we need that month is to be able to reconcile some planning issues. And we'll talk more about that later on today. On the 8th of May, we'll announce who has won a slot. And we would love to be able to give slots to everybody who applies. Basically, we will be time limited in the sense of there's only a certain number of slots available. And once the pointings are all reconciled, there's only a certain number. The VMC imaging campaign, it's actually a really cool thing. We're very excited about it. And we're glad to see that a lot of you are already. We've received quite a good number of applications. And we hope most of you, or even all of you, are watching right now, depending on which time zone you're in. We are actually going to hand over VMC to you in the sense that obviously we can't actually bring you here to ESOC to sit in the room and press the buttons, but we're actually going to take your requests, your imaging requests for this camera, and program those into the Mars Express mission planning system. And on a 3-day period in May, roughly between the 25th and 27th, the pointings that you have requested, the targets that you have requested, will actually be carried out by Mars Express, and we'll send you those images back to you when they're acquired. And your part of the activity, of course, is that we're looking forward to see your project, and your project is wide open. We want to see something scientific, something collaborative, something artistic, something really cool, as best as you can do with those Mars Express images. Quick rundown of the dates, just so that you keep these in the back of your mind. 27th of March at 12 noon CET time on the 27th of March.